All right, folks, so let's look at the first part of chapter 4 for systems analysis and design, which is requirements modeling. Now, of course, this is key. This is where we get into deciding, what are the requirements of the system. So basically, what is it that users of the system are going to require from the system? Now, this can be everything from a single data element, gee, I need to store a customer's birthday, all the way up to I have a requirement that we can run end of day reports that list XYZ, PDQ, whatever in under 5 minutes. So requirements for a system can vary greatly. So let's jump in here real quick. So chapter objectives describe systems analysis phase activities. Explain a couple of the methodologies, joint application development, rapid application development, agile. We'll go through all these. We'll look at an FDD, a functional decomposition diagram. Got some extra videos in this chapter. Make sure you watch those. Yes, they're a bit dated, bit 70s, but the speaker does a great job. We'll look at UML, and we'll go through the rest of this. We'll start talking about total cost of ownership, getting into the financial aspect of what a system costs, and that's what we'll look at in the aspect of a lab this week is total cost of ownership. So an overview of this phase of the software development lifecycle. So understand the proposed project, yes. Ensure that it supports business requirements. I think we've made that pretty clear, right? We're not going to take on any project that's not going to support business requirements, except remember those projects that we just don't have a choice of doing. Regulatory projects, for example, projects that may come from the public that say, hey, you've got to do something about your waste, for example, getting outside of IT, but you get the idea. So, and then build a solid foundation for system development, because again, this is where we start building that foundation, is with the requirements. If we miss a requirement, and it may be a big one, what's the value of the system? So great example. So systems analysis activities, so requirements modeling. We're going to look at data and process modeling, object modeling, and development strategies. So this time it's requirements. So requirements modeling, the fact of finding to describe the current system requirements for the new system. A lot of times, because we have experience with a previous system, if we're indeed replacing an older system, we can look at its functionality for the requirements. This is an observation that end users can make to say, hey, this works well in the current system, this doesn't work well, this is why we're replacing the system. Well, we need this additional functionality, for example. So data and process modeling, well, that's just the graphical representation of system data and the process or processing data. Okay, so as you can see, we'll go around and around with this idea of requirements modeling, object modeling, data process modeling, back and forth. This is the development strategies together. So object modeling, creating objects to represent things, transactions, and events. We do a whole chapter on objects. We'll get in much detail. And then development strategies, looking at trends. What is the trend today? Well, today we've gone full circle here. It used to be the mainframe, a single computer that sat in our building, many dumb terminals, and all the work was done on that computer. Then we went out to the client server environment, and that's where we had data on a server, but we did the processing back on the client. So we had a client-supported portion of the application where data was called, it processed on the client, and then was sent back, a lot of times simply for storage, back on the server. And now where we're going is almost back to the mainframe. We're going back to doing all the processing on the server. However, the difference is we're doing that inside the cloud. So a lot of the features and functionalities that we're dealing with today in information technology don't sit inside our business. They sit out in the cloud. So a great example of that would be what you all think of as Outlook. Behind Outlook is a Microsoft product called Exchange, and it's the email server version, Outlook being the client that connects to that. Well, it used to be to have Exchange, we had to install an Exchange server in our location. We would do DNS mail exchange records that pointed towards that so that the internet knew if you were sending an email to @cocc.edu, that mail exchange record, which directed the mail into our Exchange server. Today, though, Exchange is hosted by Microsoft. It's in the cloud, and it's called Office 365. So it's a huge Exchange server that manages email for a ton of clients. How do we connect to that server? Well, we can do it with the same old Microsoft Outlook that we have. We have Outlook Web Access, which is a web interface. And of course, because this is available on the cloud, we can now much easier connect our mobile devices, our tablets, any place that we want to get to our email. So there's a great example of a cloud-based system. So skills for this, well, strong analytical skills. Well, that makes sense. It's called critical thinking. The ability, you might have heard this term, to think yourself outside the box. So today, some people would actually say we're losing this skill of critically thinking. And the reason we're losing this skill is because we can go to Google and get the answer. However, the answer for a broad question like, what kind of database does my company need to be more productive, is not going to be found in Google. Now, we might be able to go out and Google and find applications that have been custom designed for our particular industry. So we might find a solution out there, as we'll see when we get into the whole personal trainer course project. And then, of course, interpersonal skills. You know, we talked about the fact that the systems analyst needs to be a translator. Well, interpersonal skills are involved because a lot of times we get multiple people with multiple opinions, and we're the one that has to be the person in the middle that kind of calms the whole storm, if you will. The fact is, when I work on projects, I want people to challenge other people. I want to challenge the ideas we're coming up with. I don't want to sit there and have everybody nod their head, a whole room of because we're going to miss something. We oftentimes what I will do is assign people who literally, I say, look, whatever we decide, you can't agree with it. You got to come up and say, well, you know, maybe there's a better way, or have we thought about this? So we don't just bandwagon and end up with a product that doesn't meet the needs of our customers. So team-based techniques, you know, team application development is huge. We're trying to develop applications faster and faster and faster. And one of the reasons is the technology is changing so fast that we need to be to market, or we need to get an application out and using it and start developing return on investment. That's a term, ROI. We love our three-letter acronyms in this field, in IT in general. But it's the idea that we need to be able to hit the market or produce an application and make it valuable to the company as soon as possible. So the object, of course, is to deliver the best possible system at the lowest possible cost in the shortest possible time. Well, that all sounds great, but does that mean that a project isn't successful if we miss a target? No, it just means we missed the target. We go back and then audit and say, okay, well, the project took 2 months longer and it cost this additional money. So instead of having, say, a 3-year return on investment timeline, maybe it has a 3.5-year. But if we use the system for 6 years, it may have been a viable and successful project. So a couple different application methods. Joint application development. So it brings users into the design process. Think about that. Users become part of the design of the system. Rapid application development uses a condensed version of the system development lifecycle, obviously, because it says rapid application development. And then Agile Methods stress intense interaction between developers and users. So we'll take a little bit more detail on each one of these. So joint application development, brings users into the development process as active participants. So it's not that they do the coding, it's that we empower them. Oh, you've heard that term before. We empower them to make decisions about the development process. Okay? Now this may mean, things as simple as, well, this is a requirement, this is how we're going to implement it. Here's another thing, here's a feature or something that we might add, and getting them involved. Because again, user involvement, creates a successful system because we start engaging the people who are actually going to use the system. Can you imagine designing, say, a hammer without consulting with the person that's going to use the hammer? Especially if we're new in engineering, boy, we might create something really, really fancy that just absolutely doesn't meet the needs. And we see that a lot in systems analysis and design, where the techies get a hold of it and they run away and with the process, and it's got this feature and that functionality and this and that and the other, but it really doesn't meet the end user's requirements. And the end user starts feeling separated from the project. Thus, they're like, oh, well, yeah, something's coming down the pike. I don't know what it is. I wasn't involved, So I think one of the best examples I can give you is back a long time, well, not a long time ago, but a few decades ago, when we were figuring out how were we going to write in space. So NASA started down this project trail of trying to create a pen that would write in zero gravity, okay, and spent, from what I understand, hundreds of thousands of dollars on this project, while the Russians solved it with something called a pencil, because a pencil isn't affected by zero gravity. Do you get the idea? So here was this project. They're like, oh, we got to create this pen that'll write in zero gravity. No, we didn't. We just needed a utensil to write in zero gravity. So user involvement, hugely important. So participants and roles, so the project leader and one or more members, participants, insulated from distractions of day-to-day operations. So the idea here with joint application development is a full focus on the project, okay? So here's kind of the roles. I'll just pause this. I don't need to go through all these, but you can see there's a project leader, top management. Why top management? Again, they're in there, even if they're not in there to engage in the actual production or design, they're in there to say, this project is important. We are doing this project. Sometimes top management is just asked by the project leader, hey, we're having a project meeting. Can you just poke your head in and say, how's it going? This is really important, or this is going to make or break the company, if it's going to make or break the company. Managers, so department level support for the project, understanding how the project must support business functions and requirements. They tend to know what the long-term goals or the short-term goals of the company are. Managers understand they have that strategic plan, so they're able to bring in that strategic plan into the project. Okay, and then users, of course, they're the operational level, so they know what they need best to do the day-to-day operations. They know what worked in the old system if we had, or they know how they currently do the job without a system. So they're a huge resource. That's why we get them involved and engaged. And of course, also from that psychological standpoint of, if they're involved and they're engaged, then when it comes out, they're going to support it. And the users that aren't involved and engaged, well, they start hearing from the ones that are, that say, oh, this is going to be really cool. Oh, it's going to cut time. Oh, it's going to give you more information. Or the best one, oh, this is really going to help make your job easier than it is today. So there we go. Systems analysts, other IT staff. Yeah, we understand the nerd stuff, the technical stuff. How are we going to build the system? Where is it going to sit? Is it going to be on a server? Is it going to be in the web? How are we going to secure it? How are we going to back up the data? What kind of hardware is needed? Is this just a single processor server? Or, do we need 16 processors at 4 cores each to run this application because the database is going to be so huge and we need 128 gigs of RAM in a server? Who knows? And then, of course, the most important person, the person that documents results. So I'm sure you've seen that in a lot of meetings you go to, right? We have people who record minutes for the meeting. That's what happens here. We need people to record, because how many times have you thought as you're driving down the road of a really cool idea and you're like, yeah, I should write that down. And then, 2 days later, you're like, oh, darn, I should have wrote that down. By having that recorder, we get that information. So a little bit more, here's a little bit more of sort of the structure, the job of each one. So you can pause this and go through this. And I'm going to go ahead and move on. So hopefully you pause. So Disadvantage of joint application, it's more expensive than traditional methods, can be cumbersome if the group is too large. So this works if we have a nice smaller group. Remember we talked about that exponential growth just in communication channels? Well, if we have a huge group participating in the project, joint application development can become very expensive and very cumbersome. So advantages though, so allows key users to participate effectively. The key users are the people who are going to put the data in, use the data that's coming out, be able to call up the system when a customer's on the phone to find out where their order is, why it's taken so long, what their order history is. Well, how many did I order last time? That kind of stuff. Users more likely to feel a sense of ownership. Yeah, that's what I'm talking about by getting them involved. They become owners of the project. And when you become an owner, you're vested. Now, from a systems analyst standpoint, we have to be careful of that because we want to make sure that we have the courage and the strength to say, wow, this project is really going awry. It's not going to succeed. We've spent thousands of dollars on it, but today is the day that I need to walk into management and say, this just is not working. Okay, so you see the difference, and that's hard to do when it's your baby, when you have ownership of that. So produces a more accurate statement of system requirements. Yes, it can, as long as, again, those techniques are followed. So rapid application development. So uses a group approach like JAD. Okay, like JAD produces requirements model. RAD produces a new system. Yep. Complete methodology, so 4 phases of the life cycle that parallels the traditional software development life cycle. Reduce cost and development time, that's what we hope is going to happen. However, be careful when we start reducing cost and reducing development time, we may be messing with the quality of the project or the product that's produced. So increases the probability of success. Yes, relies on prototyping and user involvement. Prototypes modified based on user input. So we work from a prototype standpoint, and a lot of times, especially with software development, that prototype may develop pseudocode that becomes actual production code inside the system. So here's phases of rapid applications development. So requirements planning tasks, user design tasks, you can go through, pause this, read through these, construction tasks, and then a cutover. And the cutover being, if we're dealing with an older, a previous system, we most likely are going to want to convert that data. We never, ever, 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 in my opinion, ever want to run an old system alongside the new system. And the reason being, because people are familiar with the old system, and if they can get the job done there, they'll go put the data in the old system. That's not what we want, and then the new system doesn't get used. My wife was sharing with me just the other day in a book called Freakonomics. This guy developed a system for emergency rooms, and people were like, oh, we're not going to use it. No, this is going to be terrible, because one of the things was he didn't get the users involved in the system. He did it himself. But here's what he did to psych out the users. He said he put it into a computer, into the emergency room, and said, beta system, do not touch. Well, what happened? People started using it. People were like, what do you mean I can't touch it? Oh, what does this do? And they sat down and they started getting data. And the system was so successful that Microsoft actually bought it and implemented it in 14 more major emergency rooms over the next 2 years. And it reduced the time. It greatly increased the quality and reduced the time. But imagine had he have designed that system with rapid application or JAD, where he got the users involved, it may not have taken as long to get the users to embrace the system. So you get the idea here. So 4 phases of rapid application development, requirements planning. We get with users, managers, IT staff, anybody that's going to interact with the system. We figure out what those requirements are. We then document. We're back to that documentation, documenting what the system looks like. We obtain approval, then user design, construction task. If you notice they're side by side, we can start doing these together. Okay. And then finally, once the system is built, tested, and etc., we're going to cut over. Now, full-scale testing. Now, I don't see this as part of the cutover task. Testing should be done up here in construction, and then we convert the data. We might do some testing on the data here, and then we train users and then change over or cut over to the new system. Training is important. A lot of times today we'll use what's called the trainer method. That's where we actually train people who are going to become power users to use this system. So requirements planning, team agrees on business needs, project scope, constraints, everything and then management says, yep, that's it. So go ahead, move forward. That's when we get into design and we start designing the system. We have the requirements. So a lot of times, this can be done, again, rapidly by just taking people away, going off site, getting all this stuff in a day or two or sometimes weeks, but off site where they don't have the distraction of their daily job function. So combination of JAD and case tools are used. The case tool we'll look at here in a minute. The graphical representation of what we're doing here, of the design, storyboarding, users understand, modify, and approve a working model. So that's that prototype. We work to construction, and then, like I said, we eventually cut over as we talked about in the previous slide. So objectives, cut development time and expenses by involving users in every phase of the system's development, allow the development team to make necessary modifications quickly as the design evolves. Now, a lot of times today with rapid application development, we also see the incorporation of time. And what I mean by that is we have a team, here in the US that works on the project 8 to 5. It's then shipped over to another country who's getting ready to start their day. Okay, so they're getting ready to start their day. They work on the project, and then it goes to another country that, has specialists, etc. That way we can do this over a 24/7 period of time. Now, that can't necessarily happen with the requirements gathering, but as we work into building the system and coding the system, that technical advantage, once we have that requirements and it's set in stone and it's well documented, now people can just start saying, hey, I'll work on this portion. I'll work on the user interface. I'll work on the database. I'll work on the web interface. I'll work on the mobile application interface for it. You get the idea. So advantages, more quickly with significant cost savings. Again, if we know how to implement RAD successfully. Disadvantages, not emphasize strategic business needs. System will work well in short term, but may miss long-term objectives. So because we've gone so quickly, we may miss the quote-unquote big picture. So this works with immediate, let's get it out kind of systems, okay? Not long-term 5 to 10 year systems where we need to be forward thinking to say, what might the system need to do in a few years? That kind of thing. So Agile methods attempt to develop a system incrementally by building a series of prototypes, constantly adjusting them to user requirements. Now notice, we're adjusting the prototype to the user requirement versus building a prototype in rapid application development in JAD based on user requirements. You see the difference? So we actually just start building something and then modify it once we have more requirements. So you can see how if we're not careful, this can become really costly. So developers revise, extend, and merge earlier versions into the final product. Emphasizes continuous feedback, at each incremental step. Yes, because what they're basically doing is they're going through and saying, oh, this prototype's good, but if it did this or it needs to do that or we forgot about this, we can see how if we're not careful, this can end up in huge scope creep, for example. So Agile methods, here's a nice website. You can just do some Googling on Agile methods. And also, as you're doing this, you're going to find that Microsoft has their own method based on their culture and everything else that works for Microsoft. Now, other companies may try to use the Microsoft method, and it may or may not work. Google has their own development method for these kind of things. So you get the idea here. UML modeling, we'll talk a little bit about that. Case tools, business modeling, general modeling, all used to develop a system. And actually, the first place we usually start with the system is figuring out who should be involved. And we look at the organizational chart. Okay, so we are able to go through and say, oh, well, look, this department works for that department. So if we're building a software for department A, but department B works there, we should include department B. Now, kind of funny with Agile Method, they use rugby terms. So a scrum, a rugby team, okay? So you see right there, the graphic shows them in a scrum. They're all kind of together. And if you think about it, that's what Agile is. We're all kind of going to get together and just go after the same thing, okay? So pigs include the product owner, the facilitator, and the development team. Chickens, those are the end users and stakeholders and managers. And then Scrum sessions have specific guidelines that emphasize time blocks, interaction, and team-based activities. Now, one thing I do like about Agile Methods is Agile meetings under the Agile Method are set to a time. So it's not like we're going to get in there and talk about the weather and talk about this. We do short meetings. We have a goal for that meeting. We get in, we meet that goal, and we get out. But what's the disadvantage to that? We may not have time for somebody to say, hey, folks, have we thought about this? Have we thought that this might impact? Or have we thought about adding this? Or is this really what we're looking for long term? So we do have to be careful with the advantage of time can become the disadvantage in quality. Okay? So advantages and disadvantages. Disadvantage, very flexible and efficient in dealing with change. That's an advantage. Frequent deliverables, constantly validate the project and reduce risk. Yes. But remember, those deliverables may not necessarily be based on the entire requirements of the people involved in the system. Team members need a high level of technical and interpersonal skills. Yes, we're going to work together. We're all going to need to work together. We're going to need to communicate effectively. We're going to need to understand in Agile Method, and a lot of these methods, we need to introduce the users to the technical aspect. They need to understand if we're building a cloud-based application, what that might mean. So maybe subject to significant change in scope. Yeah, we have to be careful with change in scope. All right, so looking at the time, I think that's enough for this portion. I'll come back with part 2, and we'll talk about modeling tools and techniques. Take care.